Hello everyone. In this session, we'll discuss line integral. So it says for f this f, let's say this f is having components f1 I cap, f2 j cap, and f3 k cap. Of course, this f is a function of x, y, and z, or you can also say it is a function of f of r. Other than that, the positional vector r is xi component, y, j, and z, k, right? Positional vector is always, it will always be like this only. X. Now that we know what is how to find the line integral, there are some of the properties which we should also know, and it is all about the path independence. If a vector field f is conservative or will be conservative if we have such and such conditions fulfilled here. Let's see. The line integral about the closed path will be 0, right? Closed path, it will be 0, and the line integral from a certain point P to Q will be path independent and depends only at the end point. It depends only on the end point. Also, if this field F is a gradient of a potential function, let's say F, that is, for F, this F1 component is df by dx, F2 component is df by dy, and F3 component is df by dz. Then we can say that F is a gradient and small f is a potential function, right? We know how to find the gradient, and we can move back and we can check the potential function also. So in that case, if it is having a potential function, in that case also we say that it is a conservative field. So if F, capital F, which is the vector field, is a gradient of some potential function, then also it is path independent or it is conservative. So in that case, if we have something like that, let's say F is a potential function for the field function F, then the line integral of F dot dr from a certain point, let's say P to Q, can be given as f of Q minus f of P. Obviously, it is very clear that the line integral is going to be path independent now because it is only depending on the endpoints. So we have to put the values of Q and P for the potential function F. That will give the result. And if it is, once it is path independent, we can choose any path of our choice to make the integration easy, right? So let's see the properties overall. So if this field is conservative, the line integral over the closed path is going to be 0. Otherwise, if the line integral over the closed path is 0, you can say the field is conservative. Both are same, right? Also, if it is conservative, it is going to be path independent. So it is our choice which path we have to follow to find the line integral. Any path will give the same result. Other than that, if f is a gradient of some potential function small f, then obviously in that case it should be like this. F1 should be like this, F2 and F3 should be like this. In that case also, this field is going to be conservative and the line integral can be directly found by putting Q and P for the potential function small f, right? So these are properties which are very useful. It helps you to solve the question in a very simpler manner, or maybe sometimes the calculation is not required at all.